Welcome everyone, and thanks Justin for inviting me to this workshop. I'm really excited. This is a very new experience for me. A brief self-introduction. I'm currently working at Google DeepMind as a research scientist. Before that, I worked at Microsoft Research, and I worked on a variety of different projects, including open source projects. I started open source like around 6 years ago in AutoML, automated machine learning and hyperparameter tuning, as a project called Flammo. And then I created AutoGen inside Flammo and recently renamed it to AG2. I'm been mostly working in the machine learning, AI, and the data domains. I know nothing about Web3. But recently there's a sudden kind of interest, very strong interest from the Web3 community in the AG2 framework. I'm very curious why, and that's why I came here and to learn from you guys about it. I will share like my learnings in building this AG2 open source framework and AgentOS. And then I will mainly just learn from your comments. If I make any comment about Web3, that totally makes no sense. Feel free to let me know, and it's a good learning chance for me. With that, let's get started. Let me start from maybe the beginning of AutoGen. Just a quick poll. How many of you have heard about AutoGen before? Could you raise your hand? Oh, that's great. That's not too bad. Thank you. So let me talk about the motivation. About 2 years ago, when we saw the strong power of generative AI technologies, it's very different from the previous generation of like machine learning models who can only do predictions in a closed domain. These models can generate open content like high quality text and images and so on. So the question I've been thinking about is, where this is leading us to, right? So how do we maximize the utility of these powerful techniques to build really useful applications, and what will the future applications like? So that's the question. And after a lot of like thinking and exploration, I made a very early bet on the agents, AI agents. At that time, most people still have doubts about this and whether it's a viable notion. But it's amazing to see how quickly kind of this concept is getting more and more adoption over the past 2 years, and now many people are doing that. And the reason I think that's the future of AI is that these agentic AI can not only generate content, but execute increasingly more complex tasks for humans. There's like no bound of it, essentially, in terms of capability. And there are 3 kind of dimensions that are important. The first one is about the interface. It's a very natural interface to communicate with human. And second one is about strong capability. You can keep increasing their capability and keep improving like the complexity of the tasks they can handle. But the third thing I think is less talked about, but I'm glad to hear Justin mentioning this modularity, composability, sort of idea. Because if we think one step ahead, one step further, if we think that in future agents will be everywhere, so we can build a lot of these agents to many different things, then making them interact and solve bigger problems together will make it stronger and more powerful. And also, if you think about modularity, if we think in terms of agents, instead of like some lower level abstractions like functional programming, object-oriented programming, agent-oriented programming can be a much higher level programming and make software development much easier. We need to get used to that and develop some new kind of programming abstraction concepts. So that's architecture part is something I started kind of thinking about early and try to build this multi-unit framework. Before I dive into that, let me just show a quick demo to illustrate some of the ideas. This is one of the recent release feature from the 0.6 of AG2. I think I need to, yeah. This is a voice demo, so I need to hear the voice.
I would like to cancel my flight.
Your request to cancel the booking has been noted.
I can assist you with canceling your booking. Could you please confirm which flight you are asking to cancel?
Flight 123.
You've confirmed that you'd like to cancel flight 123. Just to confirm, you're asking to cancel flight 123. Is that correct?
Yes.
You've confirmed that you want to cancel flight 123. I'll go ahead and process that cancellation for you. Thank you for confirming. Would you like a refund for your ticket, or would you prefer to receive flight credits?
Flight credits.
You've chosen to receive flight credits. I'll proceed with processing that for you. Your flight credits have been successfully processed and will be available in the next 15 minutes. If you have no further questions, I will consider this case resolved. Thank you for reaching out and have a great day.
Thank you. Goodbye.
So I may explain a little bit about what's going on. You already see that there's a voice coming out from a real-time agent that talks with the user in real time. And you also see some messages on the screen coming from different agents. The different agents are what we call like swarm agents. Each of them perform certain particular tasks like canceling a flight, modifying a flight, or triaging the task, and so on. And the real-time agent will cooperate with the other agents. And when the other agents finish tasks, a real-time agent will communicate back with the user. So from the user point of view, it's just talking with a single agent. The user doesn't necessarily need to see all the work behind the scene. But the capability of the real-time agent is greatly enhanced by the multiple agents. And also, when you try to extend the functionality of the system, you don't have to recreate all these agents. You can keep the current design and add more agents or remove some agents. So that makes it more modular and easy to modify. So I hope this example gives you some idea about the three kind of dimensions that are important in the agentic AI. Yeah, question? Yeah, this is some detail about how we make these several agents working together. Afterward means once an agent finishes its own work, what's the next step? There can be some different choices. It can handle it to another agent, or terminate, or fall back to some user proxy that asks for human input. And so these swarm agents working like this way. So one agent can decide when to translate to another agent, hand off to other agents, but they all share some context variables so that they can keep the states. And you can also configure the agent with different models, even for different agents. You can choose different ones. And what we saw is just one particular example. Let's also check some other example. Yeah, this is a different, slightly different design with different models, prompts, and architectures.
I will repeat the question to you and then get the answer from you. The question is, what is the topic of your request?
Can you help me cancel a flight, please?
Okay, so the topic of your request is canceling a flight. Okay, I have set the answer. Is there anything else I can help you with?
If you can just help me cancel the flight, that'd be great.
Okay, I understand. I can help you with that. Can you please provide me with the flight details?
Yep, it's flight number 1919.
Okay, I will repeat the question to you and then get the answer from you. The question is, which flight would you like to cancel? Please provide the flight number or any other identifying information.
Flight number 1919.
Okay, so you want to cancel flight number 1919. Okay, I have set the answer. Is there anything else I can help you with? Okay, I will repeat the question to you and then get the answer from you. The question is this the flight you initially contacted us about?
Yes, it is.
Okay, so the answer is yes. Okay, I have set the answer. I will now proceed to cancel flight number 1919 for you. Is there anything else I can help you with today? Okay, I will repeat the question to you and then get the answer from you. The question is, do you prefer a refund or flight credits for your canceled flight?
Refund, please.
Okay, you prefer a refund. Okay, I have set the answer. Is there anything else I can help you with? Okay, I will repeat the question to you and then get the answer from you.
Thank you
The
very
question is,
Yeah, how do you compare with this with the previous example, which one do you like better? First one, yeah, and what's wrong with this this particular kind of demo or agent? Yeah. 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 There are kind of a lot of like undesirable experience things, and you'll probably notice this agent keeps saying, I will repeat the question and get the answer from you, and sometimes I say, now I get the answer. So can you guess why that happens? Yeah. So I guess from a developer point of view, if we just run this example, it's probably hard to figure out the reason. I can tell you the reason is that because we need to make this real-time agent working together with other agents. So in this example, the developer used a system prompt to prompt the real-time API to take the other agent's question and repeat the questions from them and ask the user, because sometimes the flight change agent needs to get the flight number and other information, so, but they can't talk to the user directly. So they send the question to the real-time agent, and real-time agent now convert that. So this is this kind of instruction built in, but this instruction is not supposed to be kind of a spoken out, right, to the user, right? But it happened in this case. So yeah, this is, I hope this give an idea that even though the promise of AI agents is high, like a very promising future, but there are still a lot of hard problems, and it's not that easy for developers to quickly build some very good experiences. They still need to do a lot of optimization, make a lot of design choices about what model to use, or the prompt, how do we connect these multiple components, tools, human together, and so on. And I'm sure as Web3, you'll probably find other problems from the Web3 perspective, but this is some even for AI perspective, there's already a lot of challenge. Yeah, question. Yeah. Okay. Yeah. 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 Handoff is means one agent hasn't finished its work, but realized it needs help from some other agents. They can decide by the decisions made by the language model. The language model can decide to invoke a tool. That tool will translate the control to some other agents. But after work is when the agent has already done its work, now the system needs to move on, and so the agent needs to be clear what is next agent to use. Yeah. Yeah, what's happened? It's correct. It's okay to do it this way, because in this in the current design, the other agents don't really have a voice communication channel with users, so they have to go through the real-time agent. But the problem is that the real-time agent, we should make sure the real-time agent doesn't say these things, unnecessary things, to the users. Only perform the actions, but not be too verbose, right? And sometimes also not speak too fast, because we see sometimes they go back and forth. The real-time agent says something immediately, but after it sees the information from other agents, it needs to revise its communication with the user. That's also not so good. Yeah, but in general, my point is developers are when they build any useful application, they need to face a very large design space, and we want to kind of enable them to quickly navigate the large space and quickly experiment with the different ideas and find the optimal design point. So that's the AgentOS idea, and in general, there are multiple kind of decelerator for good framework, agentic AI framework, to support all the diverse needs. I will quickly kind of mention a few of them. The first one is that we realized the model themselves are not enough, or single model is not enough to build really useful applications. We often need to combine multiple models, multiple tools, and also humans of different roles, and to build a compound AI system. And it's very hard to reason about these different type of components in general, but if we can have a one unified abstraction to unify these different components to all abstract them as agents. And then it becomes much easier to just think about multi-agent orchestration. So once we figure out multi-agent orchestration, they figure out how the system will be built. But in terms of multi-agent orchestration, there are still a lot of considerations. Sometimes the developers want to use more dynamic workflows. Sometimes they want to use more static workflows that's more deterministic. And similarly, sometimes they want to use natural language to tell the agents to be more flexible, and some others, they want to use program language to be more precise. And there are also considerations such as, do we have the shared context among all the agents, or do we have isolation of the certain information from each other? Do we have a decentralized or centralized design? How do we balance like human intervention versus automation, and so on? So a generic framework needs to be comprehensive and handle all these different needs. We also make sure as the practice moves on, all the emerging kind of AI agent design patterns can be handled easily by the framework, such as like conversational patterns between multiple agents or between agents and humans, advanced prompting and planning, and tool using, and integration of multimodalities, memories, and other techniques. It's very difficult to think about to know all of these when we start designing framework, because we don't really know like what they will be useful patterns in future. But a solid framework should use some first order principles to start with some minimal essential concepts, but make sure they are like forward looking and can handle all the emerging needs. I'm sure different people will have different kind of starting points and to consider like what is the first order principle. If you have any idea, feel free to shout out or choose one of them. But I can tell you what is my choice. We basically decide to use this multi-agent conversation as a central mechanism, and we found that that's a very capable and generalizable kind of pattern that can, over the past 2 years, every time when the new technology happens, we find it's very easy to address all these design patterns with that. Okay, now I want to share a little bit of history. In early 2023, we built the first prototype inside the Flammo project, and in August, we put paper. The reason we put paper is initially we didn't plan to write a paper, but I had an intern who did some follow-up work, and he really needs this paper to cite. So Qingyu and I started write the paper and put it on archive. And on October, we moved out to a standalone repo on GitHub, and that's the time where we could really get a lot of notice and adoption and recognition. Over the years, we have seen over the past 2 years, we have seen like a lot of interesting, diverse applications from both enterprise companies and startups, that's what makes me most excited. And some of the lessons we learned from the practice are summarized in a course called AI Agent Design Patterns with AutoGen on deeplearning.ai. But since then, it has also evolved a lot. And recently, we created this AG2 fork and want to continue this community-driven effort to build this open source AgentOS. So the community has been doing that in the AG2. But even though there's so much change and new features, the most essential concepts have not changed since the beginning. So that's the most interesting. So I will mainly just introduce that with this slide. So all of that can be described with a single slide. So we want the developers to think about any arbitrary complex agentic applications in 2 steps. The first step is define agents of different roles. And the second step is to get them to talk using a concept called conversation programming. Here, the agent abstraction is very generic. All the agents share the same interface of generate messages, send messages, receive messages, and generate replies to other agents. Before they generate messages, they can certainly perform different actions using different backends, such as using language model to generate reply or use tools to execute some tasks. And they can also take human input. So these are the primitive kind of capabilities, and it unifies the different components I mentioned earlier, and makes the thinking, reasoning process as simple as just creating the agents of different roles and then putting them together. And how do we create more powerful agents from the primitive agents? The answer is we can leverage modularity. We can use the multi-page conversation of different patterns, like sequential chats, group chats, nested chat, and swarm patterns we mentioned earlier. And you can also customize your own patterns. And once we have this, for example, nested chat, we can easily put like multi-agent conversation inside one agent, so that single agent will be perceived as a strong single entity with enhanced capability. And you can recursively do this. You can compose more and more stronger agents using this way. That's why I think it's both like modular and give you a capability to extend capability in an unbounded way. So that's the kind of most fundamental kind of capability this framework offer. And as I mentioned, they can handle all the different kind of design patterns in this approach. And if you go to our AG2.ai website, you will find a link to the YouTube channel, and here are some examples of like the recent highlights from AG2. I summarized some of the highlight new features in these three categories. The real-time agent is one example of the interface feature you already see. And there are like capability features like reasoning, deep research, agentic RAG, and the architecture-wise, you already see some of the interesting features about how to orchestrate multiple agents and communications and so on. Here are some examples like what the community has been using these new features for. This is one example, no-code UI built by Wadis, and they allow users to develop these agents without writing any code, just create some configurations of the agents in a GUI, and drag and drop and connects the agents with each other using the built-in kind of conversation patterns. And this particular example is a journal editor who doesn't write code itself, but they use this system to build a agentic editor or a reviewer assignment system, so that system will automatically figure out about different criteria of selecting reviewers, like expertise coverage, conflict of interest, and so on, and automatically suggest the final reviewers. That's just a simple kind of automation for this journal editor. And there's more kind of advanced use cases like solo entrepreneurs. They often need to handle many different tasks like email management, calendar, Google Drive, project management, navigate to website, and do some YouTube video tasks and so on. They just use the AG2 framework to build agents that try to optimize everything. Underneath, they use multiple agents to handle these specific tasks. And this is also valuable. I think that they will keep extending the capability, and it's valuable for like solo entrepreneurs when they had to wear many different hats, but the time is the most valuable resource for them. And in the remaining of the talk, how much time do I have left? 3 minutes. Okay, now I'll just quickly mention the high-level reasons of why AG2 is the best open source framework to build AI agents and agentic software. The first one is that this agent-native design supports very diverse and highly sophisticated use cases. And second one is they enable people to achieve really good performance on the challenging benchmarks. And we're still making cutting-edge research to enable the most advanced agent capabilities. So fast forward some of the examples. And this is just a list of like big enterprise customer interest and the contributors from many different organizations. And we don't have a full list of these use cases, but we're trying to curate a repo called Build with AG2, and we will add more and more links. This is very a small fraction right now. But here there are more example production use cases we already know, and they span really across very different domains. For example, this NVIDIA use case is really interesting. They use agent to help the chip designers to reduce the time from days or weeks to several minutes, and in multiple production use cases already. And there are other like scientific exploration to accelerate like protein design, material design, alloying design, and most recently general purpose psi agents that can use the non-target knowledge graph to reason about different domains and generate new high scientific hypotheses in pretty much any science domain, and connect seemingly unrelated domains such as biology, architecture, music, semiconductor. And often do that better than human scientists because they can overcome the narrow kind of knowledge of a single human scientist. And similarly, people have been using AG2 for like cosmology data analysis, and also reduce like full day of work to just 10 seconds, so tens of seconds. In social science, people have been using that to simulate social like behaviors and understand how to, for example, how to cooperate in the team, and do we select a leader, or do we have a more decentralized task assignments? And the multi-agent framework is very well designed for that. And for the benchmarks, I will skip, but I just mentioned there are some very hard like software benchmarks and web benchmarks, and people have been using AG2 to reach the top performance, and for since last year. And also there are quite a lot of interesting research, like reasoning agent, capital agent, and other agentic optimization techniques to help developers to automatically figure out the best design and optimize for different metrics. The capital agent is like a single agent that manages many different sub-agents and use existing library of agents or tools, and or create new agents on the fly if needed. So this is like the agents using agents and using agents creating agents kind of idea, and that will greatly simplify. From the developer point of view, they don't need to manually kind of choose what agents to use and so on. But that's just start. It's just like a starting point, and I'm sure it needs to evolve a lot to reach a very good performance. And we have seen some example from users as well. And just very quickly mention the some example of Web3 use cases. And that I found interesting, and so some of them I think will mainly focus on like building assistance for managing like the crypto assets, right, or do transactions, and some others focus on like building a no-code development platform and use Web3 technology to tokenize the applications. But their target user is like users without development expertise. They have ideas about the design, but use their system, they can create apps and tokenize them and create generate revenues quickly. Yeah, this Furia is one example of doing autonomous trading, and this Mosaics is example of this no-code platform. Probably, yeah. Can I play this video as ending? Okay. So because the video is really made with very high quality. I think it's fun to watch.
Because that's where the impossible becomes possible. Your journey to the stars starts now. AI analyzes trends and generates high-potential app ideas, turning vague thoughts into fully realized opportunities. AI writes the code, builds the product, and deploys your app live. No technical expertise required. Grow your user base through smart, automated marketing. Why navigate the stars alone when you can explore together? Collaborate, create, and build together. Share ideas. Vote on changes. Mosaics transforms vision into investable apps, creating opportunities to fund the next big idea, or become it. Turn the unknown into a world of possibilities with Mosaics. A new frontier awaits.
Yeah. So that's like some my very preliminary kind of observation about some activities, interesting activities from the Web3 and the combination of that with AI agents. If you have, yeah, so I'll answer some questions and. Yeah, maybe let me say that after the question. Yeah, please.
Maybe since we're a little bit behind, are you going to be around for a little bit?
Yeah.
Okay.
Yeah.
Let's try to get our next speaker set up. But first, Chi, thank you.
Yeah.
Super interesting. Round of applause, please, for Chi. Thank you. Really help building the tools to make the future, right? This is great. Thank you so much.
Yeah. So since I don't have a question, we can't answer question now. Just to say that in case you didn't get a chance to ask me in this workshop, you can join the Discord or find me in other platforms. And we already have a very large Discord with more than 20,000 members. They're like very active and doing really interesting things. Thank you very much. Yeah, you are all welcome to join the open source effort.
Thank you. Thank you. One more time.